Cool. I'll probably be about.
The people at the left, can I ask you not to use the stair, please, by security? You have a lot of places at the center of the rooms.
With medical stuff, it's not all the time that you can't access the stairs.
Yeah. It's always good to know that I still get occasional nerves on doing these things. This is the 4th time I've done a lightning talk on 4 different open source projects.
Oh.
And every time it's always...
It's not easy. But I wear I often try it.
Yeah. Oh, friends here, aren't we?
I'm muted it. No, yeah.
Oh,
I'm muted it. There's a switch.
Somewhere.
I have to put it on there. Watch it started. That's okay. I realised it was on.
I mean, I remember many years ago when they passed the abortion bill, the King resigned and then came back even the day after. That's the perfect way to run a country.
Yeah,
I would have run it. I don't like that one, so I will come back again.
Because we were without a government for more than 500 days. And actually country as well.
No one's noticed.
The problem. As soon as they started, as soon as we were going to get more taxes, more shit, and more annoying and stuff. But as long as there was no government, right? I thought it was good. Administration Arduino. Oh, that's okay. That's the way it's. But you say you can say fuck or screw you or whatever in this place. Nobody would sue you. It's not like in the States.
No, it's not in my character to do that sort of stuff. But I do have a very bad.
For our next talk, Goodwin is a little jack of all trades because he is a maker, an author, a dev, sometimes a magician also, an educator. And today it will be the musician we'll have as he will explain us how to build an Arduino without a shield to make music. Let's applaud Stephen Goodwin, aka Marquis de Gouic.
Thank you. Hello. So, as that part of the slide says, my name is Steve, and as that part of the slide says, we're doing music with the Arduino. And I had the little pretext on the slide that says, no shields required. I couldn't come up with a better Star Trek joke, unfortunately, so you'll have to like it. It just means that all the music that we'll be making, and I use music in the loosest sense of the word, we'll be using this device and nothing else. So, how did we used to do music on the Arduino? A few magic numbers and the function tone. This works fine, it's not a problem. However, tone uses interrupts. And if you want to use interrupts for something else, like something useful, you can't because tone is stealing it. So, instead, we have this. This is an improvement. Instead of 2 lines of code, we now have lots. However, it is better, honest, because this is what it sounded like back in the day. And this is what it sounds like now. See? So much better, isn't it? I can see I've got an entire audience of converts already. However, this does have some improvements, honest gov. So what are they? Well, the first thing is we're doing some abstraction here. Instead of saying write to pin 8, we're actually saying channel 0, for example. Why is this an improvement? Well, if you want to switch from using digital pins to analog pins and use the pulse width modulated functionality of the board, you'd have to reprogram half your library. Well, don't. Just change the channel to be a digital pin rather than an analog one, which it knows automatically. It says if you're going on pin 7 or pin 8, it knows what's analog, what's digital, and it sets everything up accordingly. That is actually an improvement to me, because I never bother checking my pins. Also, you've got serial debugging. Without even trying, if you use the tone function, it makes a note. Whereas if you use the Armstrong libraries to make the note, you can also say, would you mind tracing out what notes you're playing and when, so you can actually debug it without saying, is the software at fault or is the hardware at fault? That's one thing you can do. And you can just change it to be a MIDI output rather than an audio output with a speaker with one line of code. Again, we've got here the playing string, which is saying, I'm going to play the note of C. However, you can play many notes just by changing this. Yes, the theme from The Exorcist or Tubular Bells Part 1, depending on how old you are. I'm assuming that's a laugh from the elder people in the audience. So, yes, you can string a whole load of notes together, but also you've got other control messages. You can change the tempo, the duration of the various notes, and you can move around the octaves. So instantly you've got some much quicker way and more effective way of changing the music, of writing music and having it run. Tone as a function and the standard note playing in Armstrong is a blocking function. Nothing happens until it's finished playing the music. However, this is moderately useless, because most of the time you want to do something else. If you're doing a game, at the end of the level it makes a little jingly noise to say, wow, you've won or you've lost. That's fine. If you're doing music during the game, for example, you're doing a little flashy light game, you can't do it. It must be non-blocking. So what we use is this idea of an update function, which allows you to do cooperative multitasking. So we don't have any interrupts whatsoever, just every frame it says, just change the speaker. Do you need to change the speaker? Have another go, just every single frame. And because this goes quick enough, you can actually generate notes like this. See, because I'm changing the pitch, because I'm not stuck with a blocking function. As you go through, you can change the pitch of that note or the volume of that note in real time. So if you want to add some vibrato to your note, you can actually vary the pitch in each update loop. So you've got a fair amount of control of what you can do with that sound. Also provided a number of input abstraction layers. I like abstraction layers. This is the analog one. He says, having to look at his notes. Your input is going to be between 0 and 5 volts. Fair enough. However, when you get to actually read the port, it's going to say it's between 0 and 4095. Okay. However, I want it to be a note. So what this does is it automatically says, I will read the input and I would automatically scale it to a note between, for example, C2 and C6. Also, you can scale the input range itself. If you have an LDR and you're building a light theremin, for example, so as you cast shadows over your light sensor, it varies the pitch of the note, which is one line of code here. Your LDR might not be able to register the full range of 0 to 4095. 0 will be complete darkness, and 4095 would mean you stuck it into the middle of the sun. You don't have that range, so you just say, well, whatever range the LDR does have, which is 1 to 500 in the case of the ones I've been playing with, that just automatically scales so you get the maximum range possible. Again, this is not complex code, this is not magical code, none of this is going to change your life. But if 1,000 people are making little music and little MIDI trigger apps or music apps, that might be 100 or 1,000 people who are writing the same really dull 100 lines of code. There's also digital abstractions as well. So here we've got two forms of toggle button. You press a button, it changes from on to off, or you press it, and while you're pressing it, it goes on. This gives you a couple of different ways of abstracting the input to make a different sort of musical instrument. And you can put debounce into here as well for free, because debouncing push buttons is the most dull piece of code you'll ever write. So, the library itself, it's broken up into parts, because my brain can only handle a very small thing at a time. So, we have the music playback, which is what we did the Exorcist theme with. You give it a string of notes, it plays the notes, one after the other, blah, 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 blah. This calls the note playback, which says, now play C, now play E, now play A, now play B. That's one extra section of the library. That in turn calls the note control. This is what allows you to switch a note on, switch the note off, and actually work in the update loop so it doesn't need interrupts but still plays asynchronously to the rest of your code. And the waveform library, which is so brand new I don't even have any documentation on it, but it actually makes some different noises. I'm not even sure if I've got them on here. Let's see. Let's try that, see if that makes a noise. Yes, it makes a very quiet noise. The waveform library lets you create an abstract wave of any type and then pump it through the analog pins on your Arduino. So you can actually use this for playing back speech if you want to take a sample, could put the whole lot into an array and then play that. You can do that. Or you can use harmonics and then actually say, right, this is a primary harmonic, there's a second, a third, and a fourth at different rates, and it will generate the wave and it will then play it through the speaker. And the analog inputs and abstractions that we've seen, plus some utility functions for those that want to know, well, what is the frequency of A above middle C? The answer being 440 hertz for those that are interested. This was the very first example that I made, partly because I play Lego and partly because I can't build anything unless it is Lego. This is a tannerin. And you may have noticed all the slides have a music quote in them. There was a Duran Duran quote there. Who got the Duran Duran title? Who's prepared to admit they got the Duran Duran title? Only me then. Jolly good. So Good Vibrations, the Beach Boys song, people think that was a theremin. It was actually a tannerin, which is basically a length of nichrome wire. Nichrome wire has a fairly high resistance for what is basically a piece of cable. So what you do is you put a crocodile clip halfway across that wire and it creates a potential divider circuit. You then take that as an abstracted into your input, so wherever you put the crocodile clip along this meter of wire makes a different note, a nice sort of sweeping note. And of course it's made with Lego. This is another thing you can do. This is the piezoelectric buzzers which you can get, as well as making a noise, are also capable of taking in input. All it does is it's just a transducer. It converts sound waves, sound energy, into electrical energy. So as well as outputting buzzer noises, if you hit them, it generates a spike like that. And then you can use the input library to say, well, as soon as the spike goes above, this indicates a trigger of a sound. And that trigger of the sound can play notes and buzzes or white noise from a sort of a snare or a hi-hat kind of a sound. And if you've put one of these under a mouse mat, or as the chap here has done, under a proper drum pad, you can actually build yourself a very small electronic drum kit with 5 or 6 of these 20p devices and an Arduino. And a speaker if you actually want to hear anything. So I think I managed to go on time, which is unusual for me since I normally talk about 10 times as long, which means I actually have time for questions, although I'm hoping there's not going to be any because I'm not very good at that bit. The thing is, I can't rehearse the questions. When I rehearse the talk, I get all my teddy bears in a row. You all do this, right? And I give the talk to the teddy bears, because if I can explain it to a teddy bear, I can explain it to a bunch of geeks. So I've rehearsed up to here. Questions, I'm kind of going out on a limb if there are any. The links which I hopefully can see, they're all at the Marquis site, which is also where I do Fosdem diaries, JavaScript, Lego, GTA, and other bits of random stuff. If you can't be bothered to type the whole URL, just go there and you'll find it. There might even be some other notes on here if I do that. There. Really, really. Nope, I wonder if we have enough. No, never mind. But just as proof, that was all running just with no shields, a piece of wire, a resistor, and the speaker. I was not. I know you can't see down there. I just wanted to prove there are no shields in this. So yes, if I have actually finished, then I will take any questions that I can in the time remaining. But I can't see how long.
So, where's a question?
Do you have an idea what the frequency range is?
No, haven't properly tested it.
Okay, thanks.
Yeah, so I'd like to give you a really proper answer. The sweep that I was doing earlier was, I think, between 200 and about 6,000 hertz. That's all audible. It has gone up to about 10,000 hertz. I have no musical use for anything up that high. Obviously, lower frequency is going to be easier because you need to change the waveform less often, so you've got scope for that, and then it's down to whatever amplifier and speaker you end up shoving at the back end. This is running so fast, you've got a fair amount of scope. So I don't think the range is going to be an issue. Plus, of course, you've got multiple channels on this, so what you can always do is you say, well, it's not, and because it's non-blocking, you can say, I'll put 3 speakers on 3 different pins, and they can all play different notes. So if you want polyphony, you can do it that way, rather than having to build a waveform with all of the different notes concatenated in.
Another question? Okay, thank you, Stephen, for your talk.
You're welcome.